All right. Next chapter. Next chapter would be algebra with non-linear relationships. So what you've done previously has always been linear, which means lines. These are going to be non-linear, so they're not going to be lines. And there's only three that we look at. We look at the exponential function. So exponential functions look something like this. Then we look at parabolas or quadratics, which looks something like this. And then the last one we look at are hyperbolas, which looks something like this. So we've got
Didn't we do one like
exponentials.
that last year?
Sorry?
The last one. That last one. I feel like
Yep.
I've seen that before.
Oh, you should have seen all three before last year.
Yeah. Okay.
Yeah. So exponentials, parabolas, and hyperbolas. Um, all right. So let's start with the first one. So what I think the biggest thing I can tell you guys that you want to learn is the shape, the name, and the equation of a generic one. So like that. You need to know the equation, the shape, and the name. The shape, the name, and the equation. The shape, the name. Actually, maybe you guys should write all three down.
Yeah.
The equation. Because if you do know that, it will save you a lot of time asking me, Sam, how do you know that was a hyperbola? Because I'm just going to say, well, that is a hyperbola because it's the name of a hyperbola. So it's better to just memorize it. So there's only three of them. One, two, three. Exponential, and that's 2 to the power of x. And it looks something like, we're going to do it in a second. But it looks something like
Oh, so
that.
X is the power.
Yeah, x has a power.
Oh, the
Yep.
heck?
So 2 to the power of x. And then that's x squared, and that's 1 on x. So the x is on the bottom. X has a power, x being squared, x in the denominator. Hyperbola, parabola, exponential. Exponentials. That's not a straight line. Like I said, you're going to see how it looks in a second. All right, I can't see the chat now, actually. Bianca, if you don't mind, if Dahlia does message or even Cara messages, just let me know and I'll just slow it down
Yeah, sure.
because I won't be able to see it if I'm on this mode.
Okay, I'll put it on my screen so I've got the chat up as well.
Thanks.
Okay.
Okay, write it all down.
Yeah.
Exponentials, parabolas, hyperbolas. So, pretty straightforward. The first few are just going to be completing the table of values. So I don't think that's too complicated. I just want to see. Yep. All right. So let's just do that. We'll just do these
Dahlia
bits.
said she's sorry for being difficult and it'll be sorted out by next week.
No, it's okay. It's all good. This one here, B. Let's do that one. So X is 0, 1, 2, 3, 4, 5, 6, 7. And all you guys are going to do right now,
Is it just
uh,
subbing it in?
you're just going to sub it in. But
Okay.
let's just make sure.
Yeah.
So, where's my calculator? Okay, hold on. I'll grab my calculator. Bianca, start subbing. Just be
Yeah.
careful. It's a power. So it's going to look
Yeah.
like this. 2 bracket 1.7 to the power of 0, to the power of 1, to the power of 2.
Okay, yeah.
And then I'm just going to go grab my calculator. Okay, first one should have been 2. Is that correct?
Yeah.
All right. 2, 1.7 to the power of 1. Then 3.4.
Mm-hmm.
Then 5.78.
Yeah.
then, and so on. I'm just going to finish it off. 9.82 or 9.83, doesn't really matter so much. 16.7, 28, and you can see how quick it gets. It gets large. So
Yeah.
40, and then 7 should be 82.
Yeah.
The reason why I want you guys all to do it the way I just explained it above is because a lot of students, usually who get used to this table of values, go, okay, how do we draw this exactly? Now, but then I'm like, but then haven't you memorized this? So you know the shape it has. You know it's not going to be a straight line. You know that it's going to start nice and small and then eventually rise up. That's
Yeah.
the idea of it. So it does shoot up pretty fast, pretty quickly. So you can see that now, obviously, with your table of values. So if I had to, there's your 0, there's 1, 2, 3, 4, 5, 6, 7, 7. And then you got all the way from 2 to 82, right? So you're not going to go, oh, it's 1, 2, 3. That's just silly. So pick a common ground. Let's say, well, split this up, right? This is what I would do. Okay, if I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I had 12 spaces and I had the number 82 as my
Divide it.
last number, I'm just going to go 82, of course, divide by 12. That's all you can do. It's
Yeah.
not going to be good. That's as good as it's going to get. So it's about 7.
Yeah.
You know, again, you're not going to write 6.8. So you're going to go 7, 14,
Mm.
21, 28, 35, 42, 49, 56, what am I up to? 63, 70, 77, 84. Here we go. At 0, it should be at 2, so somewhere here. At 1, it's at 3, so somewhere here. At 2, it's at 5.8, which is somewhere here. At 3, it's at 9, which is somewhere a little bit above. 4, it's 16, which is a little bit above. At 5, it's 28, which is exactly.
So it shoots up there, kind of at 4.
That's the idea. 6.
Yeah.
6 is 48, which is just under 49. And then 7 is 82, which is just under 84. And then just draw it. That's it. Oh. Oh, that's bad. It's not easy to draw on this, but boom. Any questions?
Nope.
Pretty easy. You just follow the table of values. But I think it's, what I really want you guys to remember is if I've got a power of x, it is called an exponential, and the shape of an exponential is that, where that's usually 1, but not always 1. So it starts pretty small for a very long time, and then eventually that's just going to get ridiculously fast, very quickly. And it just depends on the scale. So you can see the scale here. You can see the scale here is smaller, so it looks a lot faster. If I increase my scale here, if I made this wider, it'll look more like this one here. Any questions? Anyways?
No.
Easy. All right. Let me know if you guys also have any questions. Let's try this one here. Now, obviously, this is just applied, so nothing new to learn. It's just an application of the exponentials. So let's do question 1. We'll leave question 2 for next week. If $2,000 is invested, $2,000 invested at 8% per annum compound interest, then the value of the investment A after X years is given by this formula here. So 2,000, 1.008 to the power of X. Any questions at this stage? So
No.
that's the formula. They've drawn it for you, just so you guys know where this is coming from, something that you've done a million times, but maybe you haven't put 2 and 2 together. and as you're in year 12 now, everything starts to work together. So there it is. There's your compound interest formula. P is principal, 2,000.
Oh,
R
yeah.
is rate, 8%. 8% plus 1 is 1.08. You don't know how many years. You want it for infinite years. So it's just to the power of n, where P is also 2,000.
I think I'll be starting compound tomorrow because I just did simple interest.
Oh, yeah, perfect.
Okay.
So then now you know it from a year 12 point of view, you even know the graph of it. So you can see it starts pretty small at the beginning. As the years go on, it gets a lot faster really quickly.
Yeah.
So like, I mean, if you put $1,000 in every month for 40 years, compounded, this compounded. This is obviously maybe when you guys are working or whatever, but if you put $1,000 every month for 40 years compounded annually, let's say at 8%, I can tell you, if I had to do this math really quickly, which I am going to try, give me a second. Every month compounded, 8% divided by 12 plus 1. 1,000 times 0, 1 plus 8% from 12, 180. So I was trying to get it out. I think it's pretty important to see something. Divide by 1 plus 0.08 over 12 minus 1. Something like that. I've done it really quickly, but it sounds about right to me. 3514281. Yes, it's $3,514,281. So that's how powerful compounding is. That's how powerful this can shoot up. Obviously, a lot of the money is made in those last few years.
Yeah.
So you can imagine, like by the time you're in the 30th year to the 40th year, you might in the 30th year you might already have 2 million. 2 million compounded obviously increases a lot faster than if you only had $1,000 in the first year. So $1,000 is going to go very slowly, but it's not bad if you think about it. You only put $1,000 every month. So how much did you put in? You put $12,000 a year times 40. So all in all, you put in $480,000.
Oh, wow.
You put in $480,000 over your lifetime. You made $3.5 million. So it's important to understand this, especially as you girls like to move out of high school and get into university, finish uni and get into work and whatever. It's important to understand how powerful this actually is. I can safely say 75% of Australians probably don't understand finance very well. So super important. Nothing I'm going to get into right now, but at least you get to see the application of it. I'm going to rub this out so we don't get confused. That's another conversation we'll have somewhere closer in year 12. I just thought it would be interesting for you guys to see that. All right. So here it is. There's your exponential, and we can see, do you agree that it is an exponential? Look at the shape of it. It doesn't look like a parabola, and it doesn't look like a hyperbola. Hyperbola is a little more, coming down. These ones are shooting up like that, straight up, and they're symmetrical on both sides, whereas exponentials look like this. So just keep that in mind. Cool. What is the value of the investment after 7 years? Well, if you're going to use the graph looks like it's about, I'm just going to say 3,500. Graph, 3,500. But I am going to show you how to do it if it wasn't graphical. If it was algebraic, you're just going to sub it in. So algebraic would be 2,000, 1.08 to the power of 7. Let's see how good of a guess our answer was. And if they did want the answer as graphical, there's always some leniency. So if someone wrote 3.5 or 3.4 or 3.6,
yes,
they'll accept those answers.
3.28.
And this one I think becomes what you just said, 3.4, 28. So not a bad guess.
Yeah.
After how many years does the amount double? 4,000, go here. After how many years? After about 8, 9 years.
Yeah.
After 9 years, the amount doubles. By how much did the value of the investment increase? By how much did the value of the investment increase in the second year? Okay, what does that mean? So in the second year, how much did it increase? How do we read that? By how much did the value of the investment increase? Go. What do you get? What do you reckon, Bianca?
Well, if I'm looking at the graph,
Yes.
it's whatever the 1 year is, which is probably like
I like it. Okay, why'd you say
2,000
1 year?
something.
Why, why didn't you say the second year or something? I don't know. I'm just trying to, I want to work it. Your logic is right, but
Yeah.
why?
Because you kind of like you have to show how much it increased from like the past year.
Yeah, beautiful.
Yeah.
Let's just write that. How much it increased from previous year. But again, you can see that's pretty much the only way we can make the questions harder. We know, once you guys are good at it and understand the algebra, understand the graph, we can only make it harder by the wordings. It's not so much the math. So how much of the value of the investment increased in the second year? Well, in the first year, let's call it was 2,200. First year equals 2,200. Second year, it was 2,400. And of course, increase by $200.
Yeah.
Otherwise, if we have to do it algebraically, so I'll just come up here, C, and you want to get a perfect answer, so algebraically, you would have gone 2,000, 1.08 to the power of 1, 2,000, 1.08 to the power of 2, and then subtracted. So let's do that real quick. 2,000, 1.08 power of 2 gives me 2,332.8. Power of 1 gives me 2,160. Subtract 2,332.8. And not a bad guess. Increase by $172.80. So, all good? Girls, any other questions as well?
No, they haven't said anything.
All right. All good. All right, then we do the same thing with quadratics. So nothing fancy, right? Here are quadratics. They could look like this, like this, like this. What gives it away? That it's a quadratic and not an exponential, of course. So what was the definition for it to be a parabola? So this is a parabola as well. Parabola, quadratic. Quadratic is just the equation, but we say parabola for the graph.
Dahlia said power of 2.
Yeah, that's it. She's right. The fact that it says x squared, you know straight away it's a parabola. So you don't look at the x or the 3. The fact that it says x squared, x squared, x squared. So the fact that it's x to the power of 2, you straight away know it's a parabola. Again, just to make sure we can do this, why not? We'll just do D. So go ahead and try that out. Sub it all in, and then I'm going to draw it up for us. Again, they're starting at 0. So, and then how do we plug it in just to make sure you guys know that? X, you just replace all your x's for 0. So it'll look like this in your calculator.
Yeah,
0.
would use brackets, yeah.
I always use brackets when I'm subbing in my calculator, so then that way, if it's a negative, the squared becomes a positive, and my calculator will do that. And if it's positive, then it doesn't matter. It's a habit, so that I'll never get them wrong. And that's what I do, and just keep changing them respectively for the numbers. So the first one should give you -4 if you've done it right.
I'm getting some weird numbers.
They are going to be weird.
Keep going back and forth.
Sounds right, I think. Don't forget the shape of it. So this
Yeah.
one's going to be high numbers, high, 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 lower, 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 lower,
And then back
high,
to
high,
high.
high, 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 high. Something
Yeah.
like that for, obviously, if there were negatives and positives, then it was a basic case. But don't stress. That's why I say it's important to know the shape of it. Do you feel
Yeah.
like you know the shape of this now? If the answer
Yeah.
is yes,
Yeah.
yes, yes, if the answer is yes, then you'll look at it and you'll pretty much draw your parabola accordingly. You'll see what I mean in a second.
Mhm.
Negative 6.75, and then you want to give me your numbers for all of them?
Then I got -8, -7.75, -6, -2.75, 2, 8.25, and 16.
All right. I'll double check your 4 just to make sure.
Okay.
You're wrong. Just to make sure. Beautiful. All right, done. So at 0, it's -4. So let me show you what's happening. Now, this is a horrible diagram. I hope you guys never use this just positive and positive case. It should be,
Yeah.
right?
Going,
That's
yeah.
how we're used to it. But so let's have a quick look. X is 0, Y is -4. X is 0, Y is -4. We agree with that?
Yeah.
X is 0.5. Let's call these 0.5. Or can I do this? 0.5, 1, 1.5, 2, 2.5, 3. Oh, no, I won't have enough. All right, 0.5. This is 1, 2, 3, 4. Why are they squeezing in so much? Very, very bad. Anyways, -4, 0.5 is somewhere here, and that's -6.75. So that's even lower.
Oh,
So that's there. You agree with that?
yeah.
At 1, it's -8, so even lower. -8. At 1, it's there. Then at
Negative.
at 1.5, it's actually higher.
Yeah.
So it looks like we found our lowest point.
Yeah, that
Then
is.
2, it's -6. At 2, it's -6, so somewhere here. At 2.5, it's -2. At 2.5, it's -2, so somewhere here. At 3, it's +2. At 3, it's +2. So if that's, just say that's 1, that's 2. At 3, it's +2. At 3.5, it's 8. Oh, well, that's bad. Let's run that out. At 3, it's 2. The scales of this. Okay, let's just do it with 2, 4, 6. At 3, it's at 2. At 3.5, it's at 8. And then at 4, 8, 10, 12, 14, 16. Somewhere there. Yes? Do you see the parabola happening?
Yeah.
So let's just say if I did some negative numbers, you would have seen this. It would have come down. You would go to your lowest point, and then,
Back up.
and that's your parabola. Like I said, you need to know the shape. The shape is like this. So you got to eventually go down, 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 down. You meet the lowest point, and then up, 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 up. And that's why that happened there. Went down, 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 and then up, 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 up. So just trust in the graph. I know the numbers look weird, like it was getting higher and then lower and then higher or whatever. Don't worry, it will work out. Do you want to try one on your own, or shall we move on? What do you guys? What do you reckon?
I think that's okay.
Yeah, it's just literally just plotting numbers and then just following the dots.
Yeah.
Or the shape. If you can memorize the shape, that would be super, super important. Yeah, that's the question 2 because it's an upside down parabola. The graph shows the height above the ground of a ball T seconds after it's thrown into the air from the top of a building. So it started off at 20 meters. We can see that from the top of the building. You throw the ball, reaches somewhere here, and then comes down to the ground. We understand how this is working,
Yeah.
and we understand how this is describing the motion of the ball that's been thrown. So Sam's somewhere here. He throws the ball, gets it as high as he can, and then eventually, obviously, the ball's got to come down. How long did it take for the ball to hit the ground again, I guess?
5 seconds.
How long did it take for the ball to reach the same height that I threw it at? Same
4.
height. Yeah. So that means I threw it from here. So it
Yeah.
took 4 seconds for it to come down to where I threw it,
Yeah.
and which usually makes sense because if it takes 2 seconds for it to go up, it should take 2 seconds for it to come down to the same place.
Oh, okay, yeah, that makes sense.
That's the logic there.
Yeah.
Anyways, let's have a read what this question is saying. What was the maximum height reached by the ball above the ground? What's the maximum height? What number do you want to pick?
36.
How high was the building? 20?
20, yeah. That's where where you threw it.
How long was it before the ball hit the ground?
5 seconds.
Easy, right?
Yeah.
All right, we'll move on. I think we're up to more quadratics. Complete the table values, sketch the graph. What will be the length? What is the maximum possible? Oh, good. Very good question. All right, done. All right, in your books, I actually want you to write this one down because this one is a common exam question, actually. So this is pretty much how it would be worded. They're not really going to test just a basic one like this because they might as well apply it. There it is. They can do table of values. You can sketch it, and there's the questions. So let's copy that down. I think as a question and just like write HSC style question because that would be a very common one to come up in your exams. So I think actually copy the question down. I think it'll be good. So take your time. Christian, you made it. Welcome to the class. It's recorded, but I'll talk to you at the end of the lesson, I think, because you've got a bit of catching up to do anyways. So right now they're just copying this particular question down. This is a HSC exam question. Bianca, just let me know if you're done with it.
Yeah, almost.
Okay. And obviously the topic would be nonlinear relationships. Take a note of that. Christian, same thing. Copy it down. I'm not sure if you heard me before, but copy it down.
Okay, yeah, I'm done with the copying stuff.
Okay.
How would I put it in my calculator?
Say that
Because
again.
how would I put it in my calculator? Do I just sub in the L
Yeah.
parts?
Yeah,
Yeah.
right. So complete the table of values. You know that A equals to this formula, 36L take away L squared.
Okay.
What is L equal to? 0, 4, 8, 12. So what you're going to write in your calculator is this: 36,
Mm,
open bracket, L minus L squared, where L is for the first one,
0.
0 and 0.
Yeah. Okay.
So as long as you put it in exactly like that, your answer should be 0 for the first one. Then the
Yeah.
second one, you put in
4.
4 and 4. Correct.
140 for that one.
140. Thank you.
Yeah.
And
And then
everybody else,
280.
280. Yep.
Then 420.
420.
560.
Too quick.
Then 700. Then 840.
840.
Then it is 980. And then 32 is 1120.
1120.
Yeah.
No, it doesn't look like they did this graph very well. Because you can see again their scale, they've gone up by 25, but at 32, it's 1,000. Like they're all the way up here. I don't understand. But anyways, let me maybe I've missed something. But let's have a look. If the stockyard is to be a rectangle and have a perimeter of 72 meters, then the area of the yards given by this formula, where L is the length of one side. Complete the table of values. Yep. Sketch the graph of this. And yeah, that's the problem. If I'm going to sketch this pretty much after 12, it's not going to help much. But well, it is what it is. What can you do? So at 0, it's 0. At 4, it's 140. At 4, it's 140. At 8, it's 280. So at 8, go up to 280, which is just somewhere here. And then at 12, it's 420, and that's already past 325. And then anything after that is just a lot larger. So it looks something like this. Oops. It'll just get larger and larger and larger.
Yeah.
So that's what they wanted. I guess that's all you can draw. What will be the length of the stockyard if it is to have maximum area? What will be the length if it is to have maximum area? Well, that's the problem. The way you guys have done it, I'm not showing its maximum area. Are you sure you got these numbers right? Let me make sure. 36, 12 minus 12 squared. No, it doesn't look like you did. 36, 4 minus open bracket 4 squared. No, you've done something wrong. These numbers you've got is not right.
Oh, I didn't put the square root. That's why.
Oh, square root squared.
Oh, square, sorry. Yeah, I didn't do the square.
Oh, oh.
You're wrong.
All right, 120. I was wondering, like, why is this happening? All right, 8. 8. 224. At 12. 288. Christian, you understand what I'm doing right now? Subbing in numbers. 16. 320. You've got to go and unmute yourself first, Christian, unless your mic isn't working. Then just type and let us know. At 20, it's also 320. I'm going to check that. Yep. 24. 288. Yeah, 20, that's better. 224. 224. And I'm guessing a 32. it should give us back to 128. Perfect. All right. Confirm if we understand that.
Yeah.
Yeah, absolutely. All right, let's draw it again. 0, 0. 4 is 128, which is there. 8 is 224, which is just under there. 12 is 288. 12 is 288, which is somewhere there. 16 is 320, which is there. 20 is 320, which is also there. And then 288, 224, and then last one is 128. So it looks something like this. Oh, really bad diagram, but that's because I've got to draw it on this tablet. For you guys, it should look a lot more smoother. So something like that is what you're aiming for eventually. Any questions?
No.
What will be the length of the stockyard if it is to have maximum area? So where do you think the maximum area is going to occur from this diagram? Would
Like
you say?
peak, like
Sorry?
at the top there.
At the top. And
Yeah.
what do you reckon that number is? Like what length do you think that is?
Probably 18.
It is actually 18. It's going to be
Yeah,
right in the middle.
Yeah.
So 18. 18 is correct. 18 meters. What is the maximum possible area? That means you want to find this number now. How do I go find this number? Don't overthink it. You know that the length is 18. How do I find the area at that point?
Just sub it in.
Yeah, right. You got the formula. Don't forget,
Yeah.
36L minus L squared. So 36, 18 minus 18 squared.
Yeah.
And that would be the maximum possible area that you could get. You can't actually get it larger than this. So you can copy the two questions down. Write the length for maximum area would be 18 because it's symmetrical.
Mm-hmm.
And maximum possible area, you've got to sub it in to find that, which is 324. So the highest number you'll ever get to is 324. Actually, it says not 325 there. I'm just going to rub that out. That's 325 there. And that means that becomes 324. 324. Otherwise, your graph would have had to look like this. Oh. And who would draw that? Okay, all good. Keep going. Oh. Can the graph be used to find the area if the length is 40? Can the graph be used to find the area? That's like last week's question. Remember last week's problem I said?
Yeah.
Be careful. So what we're going to do is, okay, well, let's see. Area equals 40 for the length, right?
Mm-hmm.
Let's see what it gives us. So sub that into your calculator. And if it gives us something that makes sense, then sure, why not? I mean, you can. But what does it give you? It gives you...
Oh, negative 160. Yeah.
You can't have
And
negative area. So answer is no.
No.
It's exactly like last week. I said, except be careful. Sometimes they might use temperature.
Yeah,
They got
that's
just to
okay.
work, and that can, yeah. So you just got to be aware of that. And that's it. It's pretty much the question you'll get. How many marks will be in your exam? This will be worth 2. This is usually worth 2. This is worth 1, 1, and 2. So 4, 5, 6, 8 marks.
Huh. That's decent for that question.
I know.
Yeah.
But the problem is if you stuffed up here,
Yeah,
it's
me.
and everything else. Oh, not everything else is wrong. It's everything else. If you followed through and you wrote the wrong answer, sorry, you wrote the right answer for the wrong question.
Yeah.
you can still get 6 out of 8, let's say. So you'll get 0 here, but you could get 6 out of 8 for everything else.
Yeah.
So it's not, I mean, a big issue, but still. Done. All right. Christian, I just need to know, is your mic working? If not, can you just type in the chat so Bianca can let us know you're here and you can hear us. Yep. So his mic's not working, but I think he can hear us, which is good. Yep, all good. I'll talk to you afterwards, like I said. Just let us know if you have any issues. You can just type in the chat. And then Bianca will usually let me know if there's any problems. Okay, hyperbolas. Again, how do we know it's a hyperbola, Bianca?
Because it's a fraction and the x
divided by
x.
X at the bottom. See, this is a fraction.
Yeah.
But that's not a
No,
hyperbola. That's actually a line. That's just half x, which is just something like that. So be careful. Yeah. X has to be in the denominator is the biggest thing, and they're hyperbolas or hyperbolic functions, and they look like this. Same thing, hyperbolas. All right, perfect. Complete a table of values and sketch the graph of each hyperbola. All good. Let's do it. So we have this particular function. Again, 8 on x. We've got our graph. Let's sub it in. So you're going to just sub in x is 0.25. So the first one, you sub it like this. The next one, you sub it like this. All right, you guys, make sure you can do it in your calculator. So go and work that out. 8 on 0.25 should give me 32. 0.5 give me 16. That should be 8. That should be 4. That should be 2. That should be 1. That should be half. That should be a quarter. I'll wait. Let me know it's all good.
Yeah, I got those.
Yep, done. Yeah. Anybody else? Any questions?
No, I think they're good. Yeah.
Perfect. So we graph this at 0.25. So you can see x is 4 here.
Mm-hmm.
X is 4, it's 2. So at 2, which is half of this, at 2 it's 4. Yeah. At even closer, it's 8. At even closer, it's 16. At even closer, it's 32. I mean, they didn't give me much room here, but it doesn't matter. And then at x is 8, at x is 8, y is 1, x is 8, y is 1. At 16, it's smaller, and at 32, it's even smaller. But like I said, I think if you have memorized it, now this one just worked out like this because of the scale they've given me, right, which is not a good scale. It should more look like this. But it's okay because the scale they gave us, it looks like more like an L. It is what it is again. I can't do much there. But you can see, that makes sense, right? It's got to look exactly like a hyperbola. We agree?
Yeah.
And when you know it, you know if this is a hyperbola, you already know the shape of it, you know the name of it. You'll know if these numbers make sense. So if these somehow started to look like this, like an exponential, you'll know you've done something wrong.
Mm-hmm.
If it looks like a parabola, you'll know you've done something wrong. So the numbers make sense. All right, I'm just going to move on because I know these are easy. It's more of the application questions that we want to look at. So let's look at this one. All right, Greg wants to borrow $600 from his sister. She agrees to lend him the money, interest-free, provided he repays a fixed amount each month. The graph shows the amount of each repayment for a different number of months. So he starts off with a repayment here at the beginning, and he keeps reducing the repayment as the months go on because Because he wants to he'll reduce the repayments because obviously he's paying back more money at the beginning. But the problem is he repays a fixed amount each month. Okay, fair enough. Let's continue reading and see what's happening. How much will the monthly repayments be if Greg... Oh, there, I thought so. How much will the monthly repayments be? So how much will the monthly repayments be if Greg agrees to repay the loan over 8 months? So if he decides to go, yep, I'm happy with it at 8 months, how much does he pay back? Scroll across, take an educated guess. We're going to go with 80.
80, yeah.
$80. That was easy. Over how many months will Greg repay the loan if he pays $120 per month? So if he decided to increase it, how many months would that be? So if it was 120, somewhere there, go across.
About 5, yeah.
5 months, which makes sense. You pay less, you pay less, you pay longer, you pay more. If you pay more, you finish it off quicker.
Yeah.
Does that much make sense? Yep. If Greg wanted to pay $90 per month, how many months would it take to repay the loan? Briefly comment on the sense of your answer. If Greg wanted to pay $90 per month, if you wanted to pay 90, somewhere there, go across.
6.
Should be 7.
Yeah.
I'm just going to say 7 months. Briefly comment on the sense of your answer. I think the problem is there's $600. Yeah, you see it, right? Greg's borrowing 600.
Yeah.
$600 borrowed. You got to always go back to the question if they're going to ask some stuff like that. Oh, there's no problem. I thought it was going to be a problem. No. Briefly comment on the sense of your answer. 7 months. I don't know. Read off the graph. Nothing there. I thought this was actually going to be 560, although it's 630.
Okay.
So yeah. 7 months. All good. No issues. I thought it was going to be a different style of question. Could the graph be used to find the amount of each repayment if the loan was repaid over 40 years? Comment. Yes, but because this is number of months, right? 4 years.
Yeah.
You're going to keep doing this up to 48.
Oh, it's going to be so small.
Yeah, yes, but the scale would be so small, it will almost be useless to use. So I'm not going to say no, because could the graph be used? I mean, technically you could, but it's going to be so close that it's almost useless. So it's more of a no than it's a yes. But I'm just going to say on technicalities, the answer is yes, but I do have a but. The scale will be so small, it'll almost be useless to use because you got to think about it. It's going to keep going like this. By the time it gets to here, you're going to go to the side. You're going to say, "Oh, Sam, it's I don't know, $1.50." Okay, how do you even know? So you're going to take a very, poor guess even. It's not going to be a good guess. Greg finds he needs to borrow $840 and his sister agrees to the same terms. So he finds that he actually needs to borrow more than they initially thought. Complete the table of values. Draw the graph on the diagram above. Okay, so let's do it. 840. All right, so again, you're just going to sub in n equals to 1. 840 over 1. 840 over 1 is 840. 840 over 2, 420, and then so on. I'm just going to quickly do that. 280. Let me know if you guys disagree with anything. 168. 140. 120. 105. There's no 9, that's a 10. 84, and then a 12, it's 70, right? And then we've got to draw it above. So one is at 840. One, so let me rub all this out and draw a different color. One, it's at 840. So at 1, it's somewhere here. At 2, it's 420. At 2, it's 420.
3 is 280.
Thank you. 3 is 280.
4 is 210.
210.
5 is 168.
168.
Then 6 is 140.
140.
7 is 120.
120.
8 is 105.
105.
And then 10 is 84.
10 is 84.
And 12 is 70.
70.
Why did I skip 9?
I don't know. Maybe because it doesn't give you a nice number.
That's weird.
Alright, and something like that. And that's 4 marks there. Use the graph to find approximately how much extra Greg would need each month to repay 840 rather than 600 over 9 months. Oh, that's why they didn't do it.
Yeah.
How much extra would Greg would need to pay each month? Okay, 840 compared to 600 over the 9 months. Well, at 9 months, we're going to just go with 100 for the orange one.
Mm-hmm.
So at 9 months, it's $100. And at 9 months here, I think we said that should be about $60, I would say.
Yeah, round about.
Of course. How much extra? 100 takeaway. Very hard to see. 100 takeaway. 60, $40. So, what do you reckon? Easier than last week, isn't it? This stuff.
Yeah.
It's not actually that hard for nonlinear. Even though it's very poorly done. And the reason why it's poorly done is because students don't memorize the equation, the name, and the shape. If you can do that, it's actually, they're very, very straightforward.
Say like a multiple choice. Could they put like, what graph is this?
Yes, that is actually a very common multiple choice.
Okay.
Yeah, we'll even do one in a sec. So I think they've been asked every year though, just so you know. So it's actually super common.
Yeah.
Okay. Direct variation. Okay. All right, very easy. These ones are not hard, and then there should be indirect, right? Yep, and then I think we're done with this chapter as well. Very good. Okay. Very straightforward. The first thing you want to, I guess, learn is direct versus inverse or indirect. Inverse or indirect variation. And the biggest difference and the most important difference between the two is direct variation is y equals to something x, whereas indirect variation is y equals to something on x. So y equals to something x, y equals to something on x. Because it's a variation, we're not sure how they vary. I'm not sure if it's, 2 times bigger, 3 times bigger, 20 times bigger, a half times bigger, whatever it is. We're not sure. We label that by k, and same thing with this one. So this is kx times, whereas this one's k divided by x. Pretty straightforward.
Yeah.
And then there's always 2 steps to these. Step 1, so if you guys can just memorize that, at least you can get easiest 3 marks you probably can get. Step 1, step 2. Step 1, find k. So the first thing is usually to find k. They'll give you x and y. Find k. Step 2, find x or y according to the question. Depends on question. Depends on question. Is that fair enough?
Yeah.
Step 1, find k. That means they will give you x and y. Step 2, find x or y depending on the question. Because then once you find k, you have your equation. All right, let's do it. It says p equals k times y, ky. See, that's direct. P equals ky. First find k if p equals 72, but then I'm going to say that. So you guys got to actually memorize step 1, step 2. First find k if p is 72 and y is 3. See how I said? They're going to give you your y and x value to find k first. So p is 72. K times y is 3. How do I get rid of times 3? Divide. So 72 divided by 3 gives you k equals 24. That's your step 1. So technically you have this new equation. P equals 24y. Step 2, you got to find x or y. So you got to find the left-hand side or the right-hand side, depending on the question. It says then find y when p is 288. Well, 288 equals 24. Y, again, how do I find y?
Divide by 24.
Divide by 24. You can see why I emphasized algebra for such a long time.
Yeah.
You know, you guys remember you probably did it again with Daniel and stuff. It's just I kept doing it again and again and again because it's super important.
Yeah, it shows up in a lot of topics. That's why.
It's almost every topic.
Yeah.
All right, and again, let's make sure we get this down pat. So there it is, m equals a times t squared. You've got to find that a. M and t are your variables. So first find a, m is 18, equals a times t squared, 6 squared, that's 36. And then divide by 36. So a equals to a half. And now you've got your equation, m equals half t squared. The question says find m when t is 11. So that's easy. $60.5. All right, I'll pause there. Girls, Christian, any questions?
No, they haven't said anything.
I'll just wait another minute or so, make sure.
Christian said I haven't finished copying down question 1.
Okay, sorry, yep. You'll get this booklet, Christian, as well. So most importantly, I guess you would want to copy down the heading of direct variation and then more just the question number. Maybe some notes. Yeah, just let us know when you're ready.
Yep, he's ready.
All right. So let's look at another one. Let's look at question 4. C varies directly. So now you know it's not this one. Right? It's obviously this one. So they're multiplied, not divided.
Yeah.
C varies directly with D, and then if C is this, then find the relationship between C and D. Well, the relationship firstly is C equals KD. Do we understand that?
Yeah.
Then you know C is this, D is this, we've got to find K. Very simple. That's all. That's what you've got to always do, regardless. So 24.6 equals K times 3. How do I get rid of the times 3? I think we get it by now. Divide by 3, you get 8.2. Therefore, what's your relationship between C and D? It's C equals 8.2 D.
Yeah.
Find C when D equals to 5.
Do we use the 8.2?
Yeah,
So put that
so
into
C equals 8.2 times 5.
Yeah.
That's it. Done. And you plug that into your calculator. 41.
1. Yeah.
Easy. We'll leave question 5 for next week. Let's look at a question like this. Let's see if we can get it out. Question 3. It is known that y varies directly with the square root of x. Who wants to tell me how we would write that? Y varies directly with the square root of x. What do we think?
Well, it's the direct one.
Yep. Y.
Is it just square root x in the thing?
So tell me, y equals. Say it, because you're right. You're just not hesitating. Y equals
square root and then x.
You missed something. Go back to your notes. You'll realize you missed something.
Oh, k.
Yes, bingo. Y equals k root x.
Square root x.
If you don't write k, it can't be right because you don't know how it is. You don't know if it's twice, 3 times. You just know that it varies. Something. We don't know how it varies.
Yeah.
Perfect.
Okay.
Done. And then if y is this, and then what's step 1? Don't forget, step 1, step 2. Step 1, find k.
Yeah, find k and
find x or y. X or y. So you haven't found k yet. So now that we've got our equation, step 1, y is 243. X is 3.
Yeah.
How do I get rid of this root 3? You divide it because it's multiplied. Don't say square it, so careful. That's just a number, you just divide it. So it'll look like this. 243 divided by root 3. 140.30 if you round properly to 2 decimal places. Does that make sense?
Yeah.
Divide by this number. So technically your new equation is this. I need a bit more room. So technically your new equation is y equals 140.30 root x. Now it's saying find x when y is 460. Find x when y is 460. So it'll look like this. All right. Remember your golden rules of solving equations. Leave what is attached to the x last. So we're going to leave that square root last.
Yeah. To get rid of the 140.
Get rid of the 140. So 460 divided by that. 460 divided by 140.30 is 3.2 8. Something like that. And then what do we do to both sides to get rid of the square root? So how do I get rid of the square root now?
You square it, and then square it up. Yeah.
So square the other side, and x should equal to 10.75. Or if you use 28, it should be 776, but I used the exact answer. Okay?
Yeah.
So the only reason why that's hard is because of the equations skills, not because of this particular question. Otherwise, the question makes sense. Like, it's simple. Once you know step 1 and step 2, you're finding x or y after you find k. The questions themselves are okay. So let's have a look at indirect ones, and then if we realize we need some more help, we'll come back. Why not? Last bit. Inverse variations. Same thing. Always you're going to find your k, or your a in this case, and then after that you find x or y. So let's just look at question 2. Again, Bianca, give it a shot. If y is inversely proportional to x, so not directly, and y is this, and x is this, find the equation connecting y and x. So y equals
k on x. Is it just that?
Yeah. Y?
Yeah.
Inverse proportional to x.
Yeah.
Inverse means opposite, so that's why it's divided. And then you know that y is 24.
Yeah.
X is 4.
So just times 4.
This time? Yes, correct. So 24 times 4 is 96. Now the equation, find the equation connecting y and x. The equation is y is 96 divided by
X.
So technically this is a hyperbola, if you look at it properly.
Yeah.
The value of y, find y when x is 8. Well, that's easy.
12.
Find x when y is 72. Find x when y is 72. So now y
is
72. And then what do we do this time? Again, we're trying to still find x. What would you do now? Don't think about it too much. When you start thinking too much, I've realized you overthink. So just tell me, what's the first thing you do? Just quickly. Quick, you're still thinking. You got an over x, what are you going to do?
Times.
Yeah, we're going to times it over to bring it over here. It's going to look like this. What do you do?
And then divide by 72.
That's what so please stop stalling. Because I'm trying to help you out. If you keep stalling, you're going to start overthinking for nothing. Let it come natural to you. Just multiply it still. There it is, and then divide 72.
Okay.
All right, I'll pause again. Anyone have any questions? Maybe if you want to copy that down. Most important words you're looking for there: y, inverse, x, and then again, always step 1. You got to find k, which means they've got to give you x and y. Always, there it is. And then once you've got that, you've got your equation linking x and y. And once you have that, you can pretty much find x or y depending on whatever they want you to find. All right, any questions?
No.
All right.
They don't have to either.
Yep, question 3. This is a typical exam question, so it's not going to usually be broken up. Typical ones like this, and the problem is this is the way you guys read it. Y varies inversely with x. If y equals 12 when x equals 4, find y when x equals 8. Then you're like, I'm confused. Because you read the whole thing. A full stop in math means stop.
Yeah.
Comma also means stop or break. And then full stop means finished, stop. So just keep that in mind. Then You're laughing, but you know you do it as well, Bianca. You
Oh,
just
I
read.
know I do. That's why I'm laughing.
Yeah. So you
In
gotta.
an exam, I just do the whole thing.
Yeah. So you gotta stop. You gotta stop. You gotta learn from that now. You go, okay.
Yeah.
Stop. Stop. So y varies inversely with x. That means y equals k on x.
Yeah.
Then we usually go and try to find k, which means I need x and y. Keep going. If y is 12 when x is 4, okay,
Yeah.
so y is 12, x is 4, then I know that multiply this over, k equals to 48. So once I find k, I have my new equation, which is 48 on x.
Mm-hmm.
Then the last bit is find y when x is 8, find y when x is 8. That's easy.
Yeah.
X is 8, 48 on 8, 6. Done.
Yeah.
All right. So that's a typical question. Again, if you guys want to write that, it's probably the one you want to know because it has, you got to do everything yourself. You got to do part A, part B, part C, all yourself.
Yeah. All in one.
All right. All good.
Yeah.
Let's move on. I think we're done, aren't we? Yes. So, just like we did last week, I'll stop that recording.